Welcome. Chemical bonding helps explain why atoms join together and why they share or transfer electrons. In this course, we'll make ionic, covalent, and coordinate bonds clear, diagram friendly, and ready for ICSE board style questions. Here's the path we'll follow. We'll begin with the foundation, why atoms bond, and how valence electrons affect stability. Then we'll study ionic and covalent bonding in detail before moving to coordinate bonding and ICSE style practice. By the end, each concept will connect directly to exam questions. Bonding becomes much easier when you focus on one central question: how does an atom become stable? From there, three main pathways make sense. Some atoms gain or lose electrons, leading to ionic bonding. Some atoms share electrons, forming covalent bonds and dot structures. In special cases, one atom donates a pair of electrons, giving coordinate bonding. Once this logic is clear, ICSE questions become less about memorizing definitions and more about reasoning, comparing bonds, and drawing accurate electron diagrams. Use this course in the way that matches your current level. If bonding is new to you, start from the beginning and build step by step, because later ideas depend on the basics. If you already know some chemistry, target your weak areas, but still review Module 1 before advanced bonding. For exam preparation, use the later modules for comparison and practice. Study actively, pause, draw structures, solve questions, and review. A bonding notebook can help you collect definitions, diagrams, exceptions, and reasoning answers. Let's begin with the big question: why don't most atoms stay alone? In this topic, we'll see bonding as a pathway towards stability. Atoms combine because their outer shells are often incomplete, while noble gases show us what stable, complete shells look like. Atoms are the basic units that take part in chemical reactions, but most do not remain isolated. Many have incomplete outer electron shells, so they join with other atoms to become more stable. This joining is called chemical bonding. Hydrogen bonds with oxygen to form water. Sodium and chlorine form common salt. Two oxygen atoms form oxygen gas, and carbon with oxygen forms carbon dioxide. So, many substances around us are not single atoms, but stable combinations of atoms held together by bonds. In chemistry, stability is closely linked to energy. A particle with lower energy is more settled, so it is less likely to change or react. Think of an unstable atom like a ball high on a hill. It tends to move toward a lower energy position. Chemical bonding is one way atoms reach that more stable arrangement. Noble gases give us the clearest model of atomic stability. Helium is stable with 2 electrons because its first shell is full. Neon and argon are stable because their outer shells contain 8 electrons. With full outer shells, noble gases have little drive to gain, lose, or share electrons, so they rarely form bonds. For most other atoms, bonding is a way to reach a similar arrangement. Metals may lose electrons, and nonmetals may gain or share electrons, but the aim is the same: a more stable outer shell, like the noble gases in group 18. The most important electrons in bonding are the ones farthest from the nucleus. This outer energy level is called the valence shell, and its electrons are valence electrons. Because these electrons are the most exposed, they determine how an atom bonds with other atoms. Stability is reached when the valence shell is full. For the first shell, full means 2 electrons, called a duplet, as in helium. For most other main group atoms, full means 8 valence electrons, called an octet, as in neon. Atoms with incomplete valence shells tend to gain, lose, or share electrons to reach that stable arrangement. A full outer electron shell makes an atom more stable. Noble gases like neon already have this arrangement, so they usually have little reason to react. Other atoms behave differently. Sodium has one outer electron, which it can lose easily. Chlorine has seven, so gaining one electron completes its shell. Hydrogen has one electron, but its first shell needs two, so it often shares or gains one. In each case, bonding helps atoms reach a lower energy, more stable electron arrangement. There are three main ways atoms move towards stability. First, some atoms lose electrons. Metals like sodium often do this, forming positive ions because they now have more protons than electrons. Second, some atoms gain electrons. Nonmetals like chlorine may accept an electron and form negative ions. When electrons are transferred in this way, ionic bonding can result. Third, atoms can share electrons. Two nonmetals, such as hydrogen atoms, can share a pair so both become more stable. This sharing forms covalent bonding. The idea of a full outer shell is important, but the deeper reason for bonding is energy. Separate atoms may be in a higher energy, less stable state. If their electrons and nuclei can arrange in a way that lowers the total energy, a bond forms. The energy difference is released to the surroundings, and the bonded molecule becomes more stable. So, chemical bonding is a move toward lower energy, and stability is the result. Let's make this idea concrete. Sodium has one outer electron it can give up, while chlorine is one electron short, so they form sodium chloride. Hydrogen works differently. Each hydrogen atom needs one more electron, so two hydrogen atoms share a pair and form H. Oxygen atoms can also share electrons, forming O. The pattern stays the same. Atoms bond when losing, gaining, or sharing electrons helps them reach a more stable arrangement. In an ICSE answer, avoid saying atoms bond because they want to. Give the scientific reason. Start with stability, then connect it to a complete valence shell or noble gas configuration. Finally, mention the method atoms lose, gain, or share electrons. A strong 2-mark answer could be atoms form bonds to attain a stable electronic configuration, usually like noble gases, by losing, gaining, or sharing valence electrons. If you add lower energy, your explanation becomes even more complete. Let's bring this together. Noble gases are stable because their outer shells are complete. Most other atoms have incomplete valence shells, so they bond to become more stable. They do this by losing, gaining, or sharing electrons. This one idea explains ionic and covalent bonding, and it leads directly into valence electrons and valency next.